We live on a planet blessed with life, and the cradle for life has been the oceans. The oceans not only support life, but also affect the weather system of the planet. We have depended on the ocean, and the ocean also depends on us. With the ever-increasing demand for water, countries are looking at the world oceans to fulfill the need for fresh water. For this, desalination plants are necessary, but also have a negative effect and hence can be called a necessary evil. What a desalination plant does is takes water from the oceans or seas and purifies it of impurities to give potable water for human consumption. But just like an RO system in our homes, to produce 100 liters of potable water, the desalination plant takes in 250 liters of salt water and spews out 150 liters of highly concentrated salt water back into the ocean. This increased concentration of brine is increasing the salinity of the oceans. This is the effect of rising salinity of the oceans, which is diversely affecting the climate and is accelerating climate change. With the ever-increasing need for fresh drinking water, Egypt is planning on setting up of 17 solar-powered desalination plants by 2025 for production of 2.8 million metric cube of drinking water per day. However, the additional water requirement by 2050 in Egypt is estimated to grow by another 6.4 million metric cube per day. We at SSP have developed a technology where we take the RO rejects from the desalination plants and return 99% potable water and additionally produce high-grade vacuum salt that can be marketed to earn profits or mitigate costs for the desalination plant operator. This is one of those rare cases where the waste from a process can be transformed into wealth. At present, about 51 desalination plants are working in Egypt as per available data. All these plants are producing about 9.24 million metric cube per day of RO rejects, which is being pumped back to the sea. With SSP's technology, about 8.3 million metric cube per day of drinking water can be recovered from existing desalination plants in Egypt. This system also recovers about 462,380 ton per day of sodium chloride, NaCl, vacuum salt, with more than 99.6% purity. Other salts like potassium chloride, magnesium chloride, and magnesium sulfate can also be recovered to make the system a true zero liquid discharge system. Sooner than later, stricter environment laws will prevail to stop discharge of concentrated brine back to the seas. Adopting SSP's system can save the environment as well as be a great alternative to traditional desalination plants that can just recover water but no salts. Falling film evaporator. RO rejects or retentate will enter the system at 5 or 6% total solids. This feed will be concentrated to 25 to 26% total solids. Steam will be utilized as thermal energy for drying. The water evaporated in falling film evaporator will be collected as condensate. Evaporative crystallizer. Concentrated brine at 25 to 26% from the falling film evaporator will be fed to evaporative crystallizer for the formation of salt crystal. A 4-effect forced circulation evaporator will be used for the crystallization process. Thickener. Salt slurry received from evaporative crystallizer will be fed to thickener. Here, dewatering of slurry will be done by separating salt and mother liquor. Mother liquor will be backed to the balance tank again for further crystallization or ZLDS process. Centrifugation. Thick slurry from thickener will then pass through a pusher-type centrifuge, which separates salt crystals from the slurry, and the liquid portion is collected in a tank. The liquid portion is then pumped to the thickener or ZLDS process. Drying, cooling. The salt crystals from the centrifuge are dried in a fluid bed dryer. The salt, with 4% moisture, is fed to a fluid bed dryer through a screw conveyor where the iodization is completed. The crystals form a layer on the perforated sheet present in the drying chamber of the fluid bed dryer and are dried by means of hot air. Fines from exhaust air will collect in a cyclone separator and is collected separately. Dry salt from the outlet of the fluid bed dryer is passed to the sifter through a bucket elevator. Packing. Dry salt will be stored in silos and finally will be packed. Zero liquid discharge system. All the overflow or reject from the system will be fed to the ZLDS system for removal of zero discharge of liquid impurities from the plant. The condensate from the entire system flows into the storage tanks, which is the total water recovered by this plant. The byproduct coming out of the entire system is potable water. SSP, a sustainable solution provider for a greener and safer Earth.